You are welcome to mathematics class. My name remains the same, Bandele J.O. Today, we want to go through the application of differentiation. You know, the other time we have already had our discussion on differentiation, that is differential calculus, and we went through general formula and the chain rule. Now we want to, there are some other rule, but the one we want to study is just general formula and that chain rule. The other one is not in our scheme for now. So we want to apply our knowledge on differentiation now, and we have different areas where differentiation can be applied. One of those areas is on gradient, and that is what we want to discuss today. So the application of differential equation, that is an application of differentiation on gradient. That is what we want to discuss today. That is, sometimes a line will be given to you or a curve. So and they will ask you to find the gradient of that particular curve. What are you going to do in that situation? All you need to do is just to differentiate and get your answer. Example: find the gradient of the curve y equal to x squared plus 3x minus 1 at the point on it where x is equal to 3. When you see a question like this, you will not be thinking that this is further maths. It is not further maths as well. It's something anybody can do. Once you have the knowledge of differentiation that we have studied before, here is where one of the areas we want to apply differentiation. Anytime you are given a curve like this and you have to find the gradient, all you need to do is just to differentiate. You differentiate, then you say on it where x is equal to 3. At the end of your differentiation, you substitute for x for 3. That is to see wherever you see x, you put 3, then you get your gradient of that particular curve. Solution: given that y equal to x squared plus 3x minus 1. Since we are to find the gradient, we are differentiating. Here, we are differentiating y with respect to x, and we have dy over dx is equal to this one. Just like I told us, you multiply the coefficient by the power. Power here is 2. We have 2 times the coefficient of x here is 1. 1x, then you subtract 1 from the power, and this one will become 2 minus 1. Then we go to the second term, that is plus 3x. In that case also, the power of x is 1, and this one will become plus 1 times 3 x raised to power 1 minus 1. Then the last term, that is 1, is just a constant. You have told us before that the differentiation of the constant is 0. You can learn that one. The differentiation of that 1 is 0 because 1 is a constant. But I can still prove it for you. The other time we have already done it, maybe explain it with 2 examples. But here, if you still want it, I can still explain further because of those of you that are joining us for the very first time. This one will be minus the x here. The power of x here meant to be 0. You know, any number raised to power 0 is equal to 1. And that was the reason why x is not normally appear there. And we have it as 1. That is why we call it constant. X raised to power 0 will be 1. And if you want to work it the same, follow the formula. The same we are solving it here. That means power times the coefficient here to become 0 times 1. X raised to power 0 minus 1. You know, where I say it is 0, is 0 times any number will give us 0. 0 times 1 will be 0. And 0 times x raised to power minus 1 will be 0. That is why anytime you are differentiating, you don't need to waste your time on constant. You just take it as differentiation of the constant is equal to 0. Then we can solve our You can simplify further. 2 times 1, 2. Then 2 minus 1. We have x raised to power 1. Then here we have 1 times 3. That is plus 3. And x raised to power 1 minus 1 will be 0. And finally, we have our answer. You know, x raised to power 1 will be x. It will now be 2x plus 3. Thus, any number raised to power 0 is equal to 1. When x is equal to 3, you know, our dy over dx was given to be 2x plus 3. Then when x is equal to 3, all we need to do is just to substitute for x. Anywhere you see x in the differentiation, you put 3. This one will become 2 times 3 plus 3. And 2 times 3 will be what? 6 plus 3. And 6 plus 3 is equal to 9. That is the differentiation, that is the gradient of that curve at point x is equal to 3. All you need to do, as I've said, differentiate. After we have differentiated, then we substitute for x where necessary. Therefore, the gradient is equal to 9. Assignment. Find the gradient or the tangent to the curve y equal to 4x squared plus x at a point where x is equal to 2. All we need to do, just like that example, we differentiate. After we have differentiated, we have obtained the gradient. Gradient at x is equal to 2. Then we substitute for x to get our answer. God bless you. We have to do the assignment after we have gone through the lesson. Let's endeavor to do the assignment. Then we have to submit it into the given email. Thank you. God bless you and stay safe.